Okay, this video is for lesson 10 in geometry. So we were talking about segments and finding different lengths of segments based on some, algebraic information that we have. So first of all, we look at the information we have over here, and we're going to use that information to then find our links over on the left side that are marked there. Okay, so first of all, we look at this, and I know sometimes we miss this. It's written up at the top, usually at our paper. R is the midpoint of segment PT. So that means that PR and RT are congruent. I don't know how you want to mark this. I'm maybe going to grab a different color here. Those two things are congruent, okay? We also look down here at PT and we say, well, that's 50, okay? 50 there. So that means that PR has to be what? If R is the midpoint, PR must be 25, and RT must also be 25. So we can go over here to our left side and fill that in. We know this is 25 already, okay? So now we need to find the length of PA. Well, we know it's x squared minus 4. We know AR is 3x plus 1. And those are going to be equal to our 25 here. We're looking at that because PR is 25. PA plus AR, we'll write this here, PA plus AR equal PR. And we're going to fill in our values. So we know PR is 25. We know AR is 3x plus 1. And we know that PA is x squared minus 4. And we add those together. Okay, so we combine our like terms here. X squared plus 3x minus 3 equals 25. Subtract your 25 over. X squared plus 3x minus 28 equals 0. Remember, to solve our quadratic like this, we are going to have two answers most likely, and it does have to be equal to 0 when we solve it. So now we're looking for factors of 28, so we're multiplying to negative 28, that multiply to 3. I'm sorry, they multiply to negative 28, they add to 3. Okay, we can put our x's in here right away if you want. So factors of negative 28, we know that 4 and 7, maybe a negative 4, positive 7. We know a positive 4, a negative 7. We know 2 and 14, maybe a 2 and a negative 14, something like that. But I see right here that the very first one I wrote down is actually negative 4 plus 7 is positive 3. So we can put those in here, x minus 4, x plus 7. We solve these for for x. So x minus 4 equals 0. X plus 7 equals 0, x equals 4, and it also equals negative 7. So we need to fill that in over here. That's 4 and negative 7. All right. Now, these may be our numbers. They may not be. So I'm going to tell you, I know sometimes we had some quadratics where you had two answers, and every single time they worked. But we have to get used to checking both of these, because if we plug in a negative, say into PA, and it gives us a negative answer for PA, we cannot have a negative length. Okay, so that's where we're going to run into problems. Now, I may be seeing some issues with this already here, specifically because if we look for PA, well, let's look at AR first. Okay, plug negative 7 into AR, and grab a different color here. If we want to plug negative 7 back into this guy right there, we have, I'll just do the work here on the bottom. AR equals 3 times negative 7 plus 1. Well, look at this. We get negative 20 out of that. Now, AR can't be a negative length, so we're going to say x is actually not one of our x answers. But if we plug 4 in, we will get a 13, it looks like. So our AR length is 13. We plug 4 in up here for PA. 4 squared is 16. Minus 4 is 12. And if we plug it in, we actually don't know what AT is. So we're going to maybe have to write some links in here so we understand where these go. Okay, so we know that PA is 12. AR is 13. We don't know how to find AT, but we do know that RT is 25. Okay, well this helps us quite a bit here. So if we want AT, we're going to have to add 13 and 25, and that is 38. Okay. I am going to pause this and start another problem to tag onto the back of this video here. Okay, here we are back again. We have the same line here. We just have some different information we're going with. Now, you've seen this on pretty much all of your homeworks. I give you one line and maybe, I don't know, 3 or 4 problems to do. So over here, again, we look at our midpoint information. And then we're going to fill in some of this. So A is a midpoint of PR. That means that PA and AR are congruent. So now we can start solving. So we do know PA, we know AR, we know RT. We don't know any information except for, like we don't have an equals to anything, except for that PA and AR are the same. So I might write over here, oh, PA is congruent to AR, just as a little note to ourselves. Don't forget your segment lines in there. Okay. Remember, congruent means they're the same length. So if those are congruent, we can set our little our expressions down here equal to each other. So 3x plus 9 equals 5x minus 5, and solve from there. Now we look, I would say you guys probably like these a little bit better because there's no x squareds in there. I don't want you to be afraid of the quadratics, but these ones are probably definitely going to save you some time when you see them like this. So remember, we're subtracting 3x over and we're going to add the 5. So 5x minus 3x is 2x. Add the 5 over, gives us 14. X has to equal 7. All right. So if x equals 7, we can start some of our links here. So PR, well, first we need to know what PA is, right? So plug 7 in up for x right there. 3 times 7 is 21, plus 9 is 30. Okay, so PA is 30. I like to write them in up here too so I don't get confused. Remember, you can always do this on your homework. Just make sure you erase your numbers for the steps, or, I don't know, use a colored pen or something like that. So if PA over here, remember, is congruent to AR, then this is also 30. And that means PR is 30 plus 30, or 60. All right, RT, we maybe want to find that one next. We're going to plug in 7 for the x right there. So 10 times 7 is 70, minus 12 is 58. Got a little bit longer line here. Now PT is 30 plus 30 plus 58. So 60 plus 58 is going to be 118. RA is also 30. Okay, didn't know if I had an AR in there, just RA. Okay, and RT is 58. And that is how we solve one like that.